This one is to solve the problems with system of linear equation. Okay, so if you see my videos, I already explained that we have two different methods. One is elimination method, and another one is iteration method. We have two different types of strategies to solve system of linear equation. Okay, so these all are linear equation, but we have system or simultaneous. We will have number of equations, more than one. So if you have two number of equation, you will have two unknowns. Okay, so number of equations should be equal to number of unknown. So any types of equations can be represented. A set of equation can be represented by this form. Okay, so we call this matrix form, that is A, X, and B. And this A we call this coefficient matrix, B we call it like constant value matrix, and X is a matrix or vector for unknown values. Okay, so these are the things you have to find it out. So this problem, you can see the video. I already showed how to solve this one. And how to get this equation. This is a solution, okay? So this is not the actual problem. So please go to the video. If you already watched, I hope you understand that I already paused that snapshot of that book. I mean, this is from Chapra, okay? So, and I already described like how you can solve the equations, okay? So the main difficulties, not difficulties, the main strategies for this chapter is you have to find out the system of equations. The equations will be not given to you. Okay, most of the time, for an example, this is a spring mass system is given to you. Then you have to simplify it. You have to apply your understanding, and you have to find out the equations, something like that. Okay. Then you have to form this matrix Ax is equal to B. After that, you can apply whatever method you like. You can apply. I mean, they will obviously say that. You just apply the Gauss elimination or Gauss-Jordan elimination. Most of the time, we consider one elimination and compare with one iteration. That is the main strategy. Okay. So normally, as you know, that in the class test, you have to solve one single problem using two different methods, and then you have to compare. Most of the cases is like that. Okay, so I hope you should you have already go through, or I don't know, but you have to understand this one, and I already explained in my videos. Okay, so whatever thing I already explained, I will not explain here again. So next thing is, as I said, Gauss elimination method. In the Gauss elimination, in the video I already mentioned that. So we have two steps for the Gauss elimination. If you watch my video, then you will find out that first of all, we try to make this coefficient matrix in upper triangular matrix. Okay, so we have to try to reduce or eliminate the terms, some terminologies or some terms here from the matrix, and we try to make the coefficient matrix as upper triangular matrix. And after that, we try to use the backward substitution. Okay. So these things already explained. How we can do that, the strategy is already explained. Okay, so now, but we will solve one problem now. So we will do all together. Okay, don't worry. And next thing is we have the Gauss-Jordan elimination. Gauss-Jordan elimination is something that where we try to make the matrix, the coefficient matrix, like diagonal matrix. So we will have only diagonal term 1, 1, 1. All the elements should be 0. And in this case, normally when we consider the Gauss-Jordan elimination, we try to write the augmented matrix. Okay. So this coefficient matrix and constant value matrix, we are writing it side by side, but we use the vertical separation, two vertical lines to separate. I don't know why they don't give it, but normally we put the two vertical lines separated in order to separate the constant value matrix from the coefficient matrix. This is just like, what can I say, the way that we consider to represent the augmented matrix. And you can see that we already solved this problem. And if you continue to solve, and then we will get 1, 1, 1 more. This is the way, 1, 1, 1. You will get this matrix always, okay? And then your solution will be 1, 2, and 4. That is a straightforward direct method. So we will not have any backward substitution. Okay. So maybe we will try to solve this one. And after that, we have the Gauss Jacobi iteration. So that is very easy. Okay, so you all can solve it. So I will not solve this problem. Iteration is very easy. What we need to do in this case, if you have three equations, of course the equations will be not given to you. Most of the time you have to find it from the physical description. Okay, that's the main thing. So from this equation 1, you need to write x1 is equal to what. From equation 2, you have to write x2 is equal to what, and equation 3, x3 is equal to what. So we have this one set, x1, x2, x3. Okay, and we call this, this is the equations already given. So initially we consider every time, as the first iteration we consider x1, x2, and x3 0. If it is not given, by default values are 0. If it somehow they mention that please consider x1 is equal to this and x2 is equal to this or x3 is equal to this, then you consider that values. Otherwise, the default value is always 0. So then you will just substitute the values. Okay, so x1 will be, you have put the value of x2 0, x3 0, you will have these values. x2 will be just x1 0, x3 0, and x3 will be x1 0, x2 0. So whatever value you will get, just write it down. So that is the new x1, x2, and x3 for iteration number 2. Iteration number 1 is 0, 0, 0. So this one is actually 0, 0, 0. And for the 2, you will get just substituting the previous iteration value, that is x1 0, x2 0, x3 0. You will get x1, x2, and x3. So you will repeat the same thing. Okay. So for the third iteration, we use the same equation then, but we will put the value for x1, x2, x3 from the previous iteration. It means if you are doing iteration number 3, you need to put the value of x1, x2, and x3 from iteration number 2. In this case, x1 is minus 0.2, x2 is 0.33, and x4 is 4.57 something. So if you put that value, and you will get the new set of x1, x2, and x3 for the third iteration. Okay, so that's how we repeat. We repeat the thing. So iteration number 1 is 0, 0, 0, then 2, 3, 4. And how long you will repeat? So there will be a tolerance value. Tolerance value is the absolute error. In this case, we consider this one. So sometimes they define that, please consider this one. So in that case, if you say this is actually not relative error, this is absolute error. Absolute error in this case should be this minus this. If they said relative error, so then you need to find out. For an example, in this case, if you are calculating the error for 10th iteration, and if you are focusing on x1, so your error will be 1.000018 minus 0.9984 divided by 1.0018 multiplied by 100. Okay, so we calculate this error for x1, we have to calculate the error for x2, we have to calculate the error for x3. So we have x1, x2, x3, so we have 3 errors separately. But most of the time, when one value converge, so the x2 and x3 will also converge. Converge means the error will getting reduced. Okay. When one value satisfies the condition, most of the time x2 and x3 also satisfy the condition. So at that time, just write the value of x1, x2, and x3. Okay. So this is the iteration is Jacobi iteration, right? And next we have the Gauss-Seidel iteration. So how these are different? This one I also explained in my videos. Gauss-Seidel iteration, also same strategy, x1, x2, x3, you have to find out the 3 equations. And also you have to start like same, your x2 and x3 will be 0. Okay, so then your x1 also 0, initial condition is same, 0, 0, 0 by default. Then you calculate the x1. So you need to put x2 and x3 0 because you don't know the value of x2 and x3. So similar way, when you calculate the x2, there is a difference. Okay, you have to use always the latest available value. So in this x2, when you calculate the x2, the latest available value is what? 1 over 6 2 minus 2x1. So that x1 is not 0. You already calculate the x1 in that iteration. So you have to put minus 0.2. You cannot consider the value from the previous iteration that we did for Jacobi iteration, right? In this case, you always need to consider the latest available value. So x1 will be minus 1 over 5, 1 plus 0. In this case, x2 will be 1 over 6, 2 minus 2 multiplied by x1. That x1 will be minus 0.2 plus x3. You don't have the x3. So latest available x3 is actually 0. So you just consider the 0 here. So then when you calculate x3, then you have x1 and x2. But x1 and x2 you already calculated in that iteration. Okay, just before you already calculated x1 and x2. So you have to put that x1 and x2 in the equation when you calculate x3. So the strategy is whenever the value is available, you have to use it. Okay, for any particular variable. But on the other hand, in case of Jacobi iteration, you always use the value that you got in previous iteration. Okay? That's how these are different. So please try to check these two things. They are easy, because I will not solve these things here now because we have limitation of time. Okay, so if you compare this table, you will get the same thing, and the strategy is same. Whenever the relative value or the error is less than the expected or given tolerance value, you need to stop there. Okay, there are some problems there. Some relationship already given in case of node 1, node 2, node 3, and you have this relationship. After that, please solve this problem. Okay, so we have v1, v2, v3, and using which method? They use the maybe Jacobi method or Gauss-Jordon elimination. Gaussian iteration. So they use this method. Try to solve this one. Exercise. Please go through these values. Okay, so that you try to understand the problems. I will not discuss everything, but this is easy. Okay, so they want to make something, and that is a percentage of some percentage of copper, some percentage of zinc, some percentage of glass. So for an example, transistor will be 4x1 plus x2 plus 2x3, something like that. Try to find out the relationship. Is already given in the exercise, and the values are given, so you have to relate and create 3 equations. Okay, this is the same. You have to spend some time for these things, so I will just directly go to solve the problems. Okay, so we try to solve this problem. How about this one? Or maybe we don't have enough time. We focus on the existing one and we try to simplify it. Okay, it's better. But the equation, this one I already described in the video. Okay, so this one is also very, very important problem. But of course, this equation will not be given to you. Okay, so you have to understand the relationships. Please try to understand the relationship. Sometimes you can get this one. This is also very easy. Please read the problems. Okay, this one also you can see it in the class test, previous class test, the relationships. Okay, so there are 3 reservoir, and we need to write 3 equations from for R1, R2, and R3 based on the inlet and outlet. Okay, so try to find it out. The relationship, one is already given to you, and then other for R2 and R3 you have to find it out. Okay, so the things are, most of the time you will have these kinds of scenario where you need to extract the information and create the system of linear equation. So today, because the Gauss-Jordon elimination is a bit lengthy, we try to solve this problem. So let's try to solve this one. And this one is this iteration is Gauss elimination. Gauss elimination is easy. If you just watch the video, then you will understand. Okay, but in case of Gauss-Jordon elimination, we have more things to do. Okay, so we try to solve the problem in this way. Okay, so please try to solve this one with me. So first of all, as I said, this is a Gauss-Jordon elimination. Okay, so we write the augmented matrix. We call this A, and I try to just get the coefficients. Okay, so this is 2 minus 1. Then we have 1, and then we have a vertical line, and then 4. We have 4, 3, 4, 3, minus 1, minus 1, and this is 6. Then we have 3, 2, 2, 15, 3, 2, 2, 15. For an example, if you have something, these kinds of equation, for an example, 2x1 plus x3 is equal to 4. You don't have x2. It means that the coefficient of x2 is 0. it means that your coefficient of x2 is 0. Okay, somehow if you rearrange the equation and somehow you find this is 0, so what you will do, you will write the second equation in the first one. Okay, you cannot have 0 value, so you can shift the equation number 2 to equation number 1. That's okay. Understood? So you cannot have 0 value here, it should be non-zero value. If you have 0 value, you just think about the other equation that has no 0 value, so you change it to like that. Okay, so in case of Gauss-Jordan elimination, first of all, we try to make, you know that we have to make the matrix diagonal matrix, right? Okay, someone want to say something? In matrix, one line or double line? One line or double line? Oh, this one you give one line, double line is okay. Hardest problem, which one? Hardest problem is actually what I said, that I am explaining how to solve the problem. So there is no hardest problem. Hardest problem is, you mean the how to get the equations. So this one you try to think about it, okay? And if you just write down the equations, whatever you have in the exercise, try to find it out. Okay, then if you have the equations, then strategies are same. So I don't think that there is any intelligence if I show you how to get the equation, because it's not that much complex. Okay, you have to just understand from input and output, balancing the force upward or downward. So if you have any problem you can't solve, let me know personally, so I will try to look at that. So in this class, because we have shortage of time, so I just try to make you understand this Gauss-Jordan elimination that involves more operation, okay, that we have to do. If you understand this one, then the first one, that addition will be very, very easy. Okay, anyway, we stick on here. So as you know that in case of Gauss-Jordan elimination, we have to make the matrix, diagonal matrix, that should be 1, 1, 1, and all other elements should be 0. Okay, so how to do that? In order to do that, you must have 1. If you have 1, then no need to do, you just start for the next step. If you don't have 1 here, so you need to do what you need to do, you have to modify the row 1. So how we define, you have to write down the formula or the operation description. So in this case, R1 will be R1 by 2. Please do it. So if you divide R1 by 2, what you will get? So you will get 1, half, half, and this will be 2. Okay, and this one I'm not touching anything, so just write it down as it is. And we have 3, 2, 2, 15. Okay, and now you already have this one. So next step is, if you have the first element, it means A11, that is the first diagonal element, you have to make this one and this one 0. So all the elements below and above it, you need to make it 0 with respect to first row, because the row 1 you will fix it one row and change the other with respect to that fixed row. Okay, that is the strategy. In this case, 1 you need to fix it, right? So 1 belongs to row number 1, so we will keep the row number 1 fixed, and we will try to modify R2 and R3 with respect to R1 in such a way that your 4 and 3 will become 0. Okay, because you have to consider the below and above. Above we don't have any elements, so we focus on 4 and 3. So what we do, how we write? We write that we will change the row 2. So new R2 will be R2 minus R1. Okay, and then your R3 will be, and new R3 will be R3 minus R1. So you can see there is a gap. We need some coefficient. So that coefficient of R1 is 1. So we put the R1 is below. And the coefficient means, I am saying the coefficient just to make you understand, that is not the coefficient actually. So this is the value that you got here. Okay. So in this case, R2, that is R2 here is 4. So we put it like 4. In this case, this is 1. and R3 is 3. So that is your equation. So solve it, what you will get. Please solve it. So in short, you can make it like this. So what we will have, so row number 1 I'm not changing, so we have 1 minus half, and what is half, right? Okay. And then half, and then 2. So then R2 will be, so just calculate the values. 4 minus 4 multiplied by 1. So it means 4 minus 4, that is 0. Next is 3 minus, then you multiply by 4 multiplied by 0.5, right? That is minus 0.5. So how much is this? 5. Okay, so what is the next value? Please calculate. I will not write. I will open the chat box and I will follow you. What would be the next value? Minus 3. Okay, I just believe you. Minus 3. Okay, so minus 3. Then how about this one? Minus 2. Okay, sure. Yeah, minus 2. Okay. Okay, so okay, anyway. Next one, please do it by for me. So you no need to see this one, right? I think you already write in your notebook, so let me know. 0, of course. 3.5, okay. 7 by 2, 3.5. This one? Half. Okay. How about this one? 9. Okay. So if this is the condition, hold on. Maybe I open the new one. If you understand, if you went through the videos, actually it's easy. Okay. It's for others who just want to solve some problems. Okay. In this case, next one, you already have 1 1 1 0 0, so that's okay. We focus on next diagonal term. This is 5. Okay, so now you need to make it 1. How you can make it 1? You need to divide the row R2 by 5. So your next thing will be, your R2 will be R2 by 5. So what you will get, I'm not changing the R1, so that should be 1. Maybe I just write fraction, it should be okay. If you don't want to write fraction, you can write in division form, it's also okay. 0.5. This is 2, 2, okay. There is 2. In this case, you will have 0. Of course, 0, this is should be 1. This one should be minus 3 by 5, minus 2 by 5. This is minus 3 by 5, minus 2 by 5. Which one? 3 by 5. Yeah, you can write 0.6, no problem. Carry on. Yeah, better you fix on the decimal points, okay? So I just focus you, it's minus 0.6. This one how much? 2 by 5, 0.4. This one I think I solved this problem in the video, but it's okay. Is how much? Minus 0.4, right? And the next one, you just need to write as it is. So it should be 0, 3.5, 3.5, and then 0.59. Okay, 0.5 and 9. Okay, so just make the matrix close. Okay, so next thing is you have 1 here, so you have to make this one and this one 0 with respect to this. So how you will do? So you will modify R1. So R1 will be R1 minus with respect to R2. Similar way, your R3 will be R3 minus with respect to R2. So the R2, the coefficient is 1, you already know, and R1, it will go up, 0.5 is minus, okay? And this one is 1, this is 3.5. Okay, so let me know. Doctor, the step is always start to get 1, yeah. Then make other 2 rows 0 and then get 1 and repeat, right? Yes, right. It means you have to consider, make the first diagonal element 1, and if you have something below and above, make it 0 with respect to that. So again here, now I come, this is 0, right? Non-zero value is, you have to consider the non-zero value. So this one is 1 here. If it is not 1, you have to make it 1 and then make the up and low 0. That's the strategy. Then I will go here and I will try to make it 1, and now we don't have any elements below to it, so we will try to make all the elements above it should be 0 with respect to that row. That's the main condition. Okay, so do it. How much you are doing that one, right? So I just follow you. How much it will be? So R1 will be is minus minus plus, right? So that should be first thing we already know is 0. How about the next one? 1/5 is 0.2. This one is 0.2, you mean? Okay. And how about the next one? This element, 1.8. Okay, next. So row 2, I am not changing anything, so I can just copy it. That was 0, 1, 0.6, and 0.4. R3, that should be 0. This is 0. Yeah, how about this one? 2.6, okay. And this one? 10.4. Okay, done. Then what you need to do, you divide this the row 3 with 2.6. Make it 1. So we have 1, 1, 0, 0. This is 0. That is 0. Now we are making it 1, right? And then what else? We have 0.6. Okay, minus 0.6, 0.2. So this one is minus 0.6, 0.2. This one is how much? It means if you divide it by 2.6, so 10.4 divided by 2.6 should be 4. Right, so this should be 4 here. I haven't write this one, it means R3 will be R3 divided by 2.6. Yeah, 4. So, and these value are minus 1.8 and minus 0.4. 1.8 minus 4. So in this case, this is a 1.8 and minus 0.4. Okay, that's done. So now what you need to do, you have 1, 1, 1 here. So you change this one and this one with respect to this. So we will write R1 will be R1 minus R3 and R2 will be R2 minus R3. So this one is again 1, this one is again 1. So coefficient is, this is R1, it should be 0.2, and this one is minus which one is 0.1/5? This one is 0.6. Okay. Now, if you do it, what you will get? So we are almost done. Okay, 1 0 0 1 0 0 0. This is 4. This should be 0 actually. This should be 0 actually. How about this one? So R1 will be 1.8. So 1.81. Okay. Next, this one 2. Okay. So if you have this one, now you can see that if you want to write the equations. Okay. So you know that the equation AX is equal to B. If you want to write this one, this is A, this is B. So what you will get? X1 will be 1, X2 will be 2, and X3 will be 4. Okay, so that is the solution for you. Okay, so it's straightforward. But if you get the diagonal value, your solution will be like this. Okay, the main thing is most of the time the student could get 1 1 1. Sorry, this should be 1. Sorry, this could be they got this one, but they use different rules. If you use different rules, if you're not following this one, then you might get 1 1 1, but the solution will be not true. Okay, so you this one x1, x2, and x3 must satisfy the 3 equations. So in this case, the 3 equations are, these are the equations. If you put the value of x1, x2, and x3, it must satisfy all 3 equations. If you are not following the proper rules when normalizing, or even though you get 1 1, I mean the diagonal matrix and all elements are 0, but the result will not satisfy all 3 equations. It might satisfy 2 of those, it might satisfy 1 of those. Okay, but if you want to satisfy all these 3 equations, you must follow the rules that I explained. Okay, so that is the straightforward way. How about this one? Okay, so you want more problem to solve because we have time. Okay, this one already solved. Okay, how about this one? Let's see. An electronic company produces transistor, okay, registers, and computer chips. I am reading it for the first time. Okay, so let's try to understand the problem. So this is a company that produces these 3 things. Okay, that's good. Each transistor requires 4 units of copper, 1 unit of zinc, and 2 units of glass. In order to make this one, we need 4 units of copper, 1 unit of zinc, and 2 units of glass. Each register requires, okay, so this is the repeating 331, and this is a 331. So putting the information into the table, we get this one. Okay, that's cool. Supplies of this material vary from week to week. Okay, so how much supply they need. Okay, so it varies from week to week. So the company needs to determine a different production run each week. So it depends on the requirement. They have to run different production run. Okay, they have to make different production run. For example, 1 week the total amount of material available are 690 unit of copper. Okay, and then 510 unit of zinc, and 610 unit of glass. Okay, so you can see the column. Okay, the summation of the copper is 960, summation of zinc is 510, and summation of glass, these are 610. Convert your equation into matrix Ax is equal to B and solve them using Gauss-Seidel method. You can assume the initial component to be used. Initial components to be 95 units, and accuracy is this one. Okay. So how you can solve it? So convert your equation into Ax equal to B. Okay, right? So these are the coefficients, and these are summations are already given. So in this case, for an example, because the summations are 950 copper, right? So if you consider transistor as a X, register as a Y, and computer as a Z. So in this case, 4x plus 3y plus 2z should be equal to 960. Okay, so how many register? If you are considering a total number of copper, it depends on the register, right? So total production, we are considering total productions, and you need this unit of copper. So 4x, you can consider x1, x2, x3 should be okay. 4x1 plus 3x2 plus 2x3 should be equal to 960. Another one, same, right? X1 plus 3x2 plus x3 should be equal to 510. Another one, 2x1 plus x2 plus 3x3 is equal to 610. So you will have three equations, you have three unknown. If you solve the x, y, z, so you will get how much or how many transistors, registers, and computers you can produce per week. You can easily solve the x, y, z, or x1, x2, x3 from these three equations. Understood? Okay, so that's how you relate. Okay, so how you solve, you can solve it, I think. Then we go, which one? This is okay. This equation. So the equation, actually you have to solve the equation. In this case, okay, I just go directly. Okay, so we have 1, 2, 3, 4. This is a bit complicated. Not complicated. It means you should have some ideas. Okay. So how we get the equation for the smoking section. So in this case, this one is 1000 input, right? We consider input is equal to output. So in this case, 1000. Okay, so we make the balance or summation of it, means the summation of in and out, or summation of in minus summation of out should be equal to 0. Okay, you can consider in either way, whatever you like. So they consider is total. It means in minus out should be 0. In this case, 1000 is the W smoker. Okay, so the load is incoming. Okay, so it's positive. So you have QA. This is the flow. Okay, you can see the meter cube per hour. It means flow rate, and this one is milligram per meter cube. It means concentration. Concentration. How much? So the total will be, the amount will be QC. Okay, you have to multiply it. So QA multiplied by CA. This is input. Okay, that's cool. Then this one is outlet, right? So this one is QA is coming. So for an example, the concentration here is C1. So you have to find out what? You go above. Suppose that the starting ventilation of a property. So you have to find out the C1, C2, and C3 for this C1, C2, C3, C4, I think. For this all the rooms. Okay, so in this case, if you have considering C1, this is the C1 for this room. So and the flow is QA. So QA multiplied by C1, that is going out. That is the thing, minus. And you can see this is the exchange. Okay, so this is the exchange. If you have both arrow, so that will be like spring. If you have spring on both directions, so we have K3 minus K2 or K2 minus K1. Same thing we have to do like this. So that should be C3 because it's going from C3 minus C1 because it's exchange. So you have to consider the difference. Okay, that is the resultant going out, because something is coming, something is going. So what is the resultant going out? That should be C3 minus C1 and multiplied by not QA. In this case, we consider the mixture E13. That value should be given to you. Okay, all the values should be provided to you. So this E13 is actually 25 meter cube per hour. You can see the unit is actually same. Okay, but in this case, we cannot use QA because it is exchanging. So that's why they use E13, that is 25. Okay, next you go to the room number 2. How about this one? So in this case, it's coming. So that is QA multiplied by CB. That's good. Then what else? Then this is also coming. Okay, this one is also coming. So in this case, it's coming from C4. So okay, before going to that, if you are considering this arrow, so you can see that this is QA following here, and this is this one is QD is going out. What is coming in? QA is coming in and QD is going out. So this one coming in should be QA minus QD multiplied by C4. That's the component, okay? So you can see there is no inlet here. That is not QA. This is a direct load. So we have QA, this is going here. This is also QA, but this is QD. So that should be QA minus QD. That will be going out. If there is no QD here, so the QA will be same. But here something is going out. So that should be QA minus QD multiplied by C4 because it's coming from C4. This is the arrow. Okay. This one, exchange rate like before, C4 minus C2. What else we have? This one is going out. So QC multiplied by C2 because this is the room. So that's the equation for this part. Okay, so for the room 3, this grill is coming, that is the 2000 direct. Then is coming here, QA multiplied by C1 is coming from here. This is mixing, so this should be C1 minus C3. So you have to consider the opposite first, okay? So it's C3 minus C1 in this case, room number 1. But for room number 3, it should be C1 minus C3. Try to give some time, okay? You will understand. It's not that much difficult. And what else? Here you have this exchange sign in between 3 and 4. So that's why we have this part. And for this one also is going out. So this is QA, 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 and is going for out, right? So there should be minus will be QA multiplied by C3. Okay, and for the room 4, we have this, and this. So we have 2 exchange. So we have 2 exchange. We have one coming in, QA C3. This is the coming in, and we have one is coming out. Sorry, that is okay. That is C4, right? Yeah. Something that should be QA. Yeah. Okay, so that's the thing already given. Okay. So now if you have all the equations, then you can balance the environment. Okay, similar way, that is a bit, how about this one? Okay, let's go before going to that. The upward velocity of a rocket is given at 3 different times. If T is like this, VO is like this, okay, and T2, so T1, T2, T3, V1, V2, V3 in short. So you have this equation, just substitute the value, you will get 3 equations. So V1 will be equal to, you just need to put T1, okay, and then if you put V2, you need to put T2, if you put V3, you need to put T3. Okay, then your unknown are A1, A2, A3, 3 unknowns, 3 equations, you can solve it. Which method they will say. Okay, this one, also same. For example, I just consider this one. In this case, it's not that much complicated that I showed last time. This is straightforward. So this one is input, and we have output is, this is also in. So we have 500 and 2 C2 input, 3 C3 input, and outlet or outgoing is 7, 5, and also 5, so 17. So that's how you can also write the equation for R3 and R2. Not that much difficult, okay? And then you have 3 equations, 3 unknown, then satisfy it. So you can, they ask you to use the Gauss shuttle iterations, sometimes the Gauss elimination. As you see, this one is elimination method, one is iteration method, and you have to compare. Okay. Okay, so just hold on for a few minutes more. Which one? I just want to highlight one thing. No. Jacobi method rarely used in test. Cannot say directly. Normally, we is both are okay. Sometimes because we know that Gauss Jordan elimination involves more operation or more things to do. So sometimes we try to relax students and give Jacobi method. So it doesn't say that. It doesn't mean Jacobi method is not important. Okay, it's not like that. I just want to explain a few things here. Shit, right. Okay, important notes. Okay, so important notes, this one maybe I missed out in my video. Okay, important notes is when we have the, what can I say? This is the convergence criteria, convergence. For Jacobi iteration or Gauss-Seidel iteration, when we do the iteration, so we need to find out whether the things are okay or it will converge or not. Okay, so the sufficient condition will be AII should be equal to summation of AIJ. If no better initial estimates are available, then we can assume each component to be 0. If the sufficient conditions hold, the iterative process always converge. However, if the system is weakly diagonally dominated, in most cases, it still converges, especially when the initial guess is close to the correct solution. It means we are doing the iteration, but when it will converge, it depends on this condition. Okay, if its condition satisfied, if the the matrix is diagonally dominant, then it's convert. If it is not, then it could convert, but we have to consider the very close initial guess. So these things sometimes we try to ask the students whether the condition is converging or diverging. Okay, so let's see two examples. So if you see this example here, the condition is this one, right? I, it means 1, 1, 2, 2, 3, 3, that is diagonal element. So absolute value of this one, that is 5, okay, is greater than Aij. It means if you focus on that row, is greater than 1 plus 2, it is 3. So 5 is greater than 1 plus 2, that's okay. 5 is greater than 3, that should be okay. How about this one? Diagonal element is 1 is greater than 9, no, it's less than 9. Okay, so we are focusing here, this row. How about the third row? This 3 is less than 8, right? So 1 is greater than, but is not satisfying all the conditions. So is weakly dominant, is not diagonally dominant, is weakly. So one diagonal is okay, element is okay, but other diagonal element is not okay. So most of the bigger term should have in the diagonal term. So how about this one? Yeah, 5 is greater than 3. This one 6 is greater than 5. Yes, and this one 7 is greater than 3. So that is diagonally dominant. So this is the condition. Okay, so check diagonal dominancy. So the condition is when it's converged, when it's not converged, something like that. Okay, so sometimes it's asked like that. Okay, if no better initial estimates are available, so it means that if you have diagonally dominant, so it will converge. If it is not diagonally dominant, or then there is a guaranteed chance there is no convergences occur. Okay, so you have to keep in mind. Okay, this one I haven't explained in the video, but it's already in the slide. That's important for sometimes you might get this small portion in the class test, like 2 marks or something like that. Okay, I think I'm almost done. This is already explained. This part is also same. Sorry. What does converge mean? Converge means when you continue the iteration, your error will gradually decrease each time. That is the convergence. It means you are getting closer to the true value. So if it is diverging, so no meaning to continue the iteration, because you are diverging, you will never get the solution. There is a convergence and divergence. So please also try to solve this problem and let me know how you solve it. So this is a problem that almost same, is actually same, okay, not almost, as these problems. Yeah. sorry, this one. So in this case, this is vertical motion. So you have the what force? The weight force, mg, right? But in this case, we have which motion is horizontal motion. So we have to apply force. And in that equation, you have two springs. Here we have only one spring. That is easier. So you might get different types of combination for a spring mass system. That is also possible to have these kinds of problems. So try to solve this one. Okay. Let's try to solve this problem. So that's you need to balance the left hand side and right hand side force. Okay, and if you see the video there, I already explained the free body diagram. We call this. We have to draw the free body diagram for M1 and M2. So you will have two equations, and then from there you can get the solution. Okay, is it okay? Time also up. We try to open the attendance, right? So then I will not take the class on Thursday. Okay, so that will be direct. So I will give one question, not 15 minutes. Maybe I will give you 30 minutes or something like that. So you have to solve it. I will prepare everything in the system. So you have to scan and submit in the assignment type. Okay. And sorry, I have to go again. Lead system of linear equation will be next week. Okay. And hope everything is everyone is okay if I take the class at 9. I think one student have problem. He said he has language class, but every week or not, I am not sure. Okay, so if you don't want to consider this night time, because 1 hour I can cover by this. I mean, if I take the class in the morning, but sometimes you need to go, you need to rush. So that's why I no need to have rush in my class. That's why I put it sometimes at night. Okay. So it's more relaxing. So we can have more time. Anyway, this is section 3.